Okay, this is problem 424 from your homework. Right, so we need to find the reaction forces at A and B. Right, the pin connection is going to have two forces, an RAX and an RAY. The roller is only going to have one reaction force. Okay, and that will be RBY. Okay, so we can start by doing sum of the forces X are equal to 0. So we have RAX going in a positive direction, and then we have, this does not have an X component, this does not have an X component, this does. So that would be the X component of that force is also going in a positive direction. We normally denote going to the right as positive. So it would be 400 pounds times cosine of 60. Alright, so then we end up with RAX is equal to negative, and now I just need to plug in 400 pounds times cosine 60. Okay, and that is in fact equal to negative 200 pounds. Okay, what does that tell us about RAX since it came out negative? I drew it in the wrong direction. If you look at it though, because this is the only other X component force, it had to be going in the other direction. But I intentionally drew it backwards so that you could see that. Alright? Now if I write RAY, that's not really going to help me very much because I don't know RAY and I don't know RBY. Alright? So it's awfully convenient if I just go ahead and write the sum of the moments. I can write the sum of the moments around A or B, but I think I'm going to go ahead and do the sum of the moments around A because there are two forces at that pin connection. Alright, so the sum of the moments at A are equal to 0 because it's in static equilibrium. So RAX and RAY don't contribute. Alright, we're still using the notation that counterclockwise is positive. This 124 pound force is going to cause a clockwise moment. So it's going to be negative 120 pounds times 2 feet. Okay, the next force will also cause a negative moment, a clockwise rotation, 800 pounds times 10 feet. Alright, now the 400 pound force has an X component and a Y component. Alright, so here's the Y component. Alright, and here's the X component. The X component is in the line of action, so it's not going to contribute, but the Y component will. Alright, and it's really this little arrow is really there. Okay, just so you'll be sure to understand the point of application. Alright, so let's go ahead and add that. That's also a negative moment. So it will be, stretch this out a little bit. Okay, it will be negative 400 pounds times, okay, 8 plus 7 plus 2, 15, 17 feet. Alright, and then the last one would be RBY, and it's positive because it's going to cause a counterclockwise. If I was pinned, had my thumbtack in point A and pushed up at B, we would want to go that way. Alright, so that would be BY times, let's see, that is 20 feet. Alright, so now I just have to plug in and solve all this. Alright, so let me work on my calculator here a little bit. Oh, you guys notice what I didn't do? I didn't make this the y component of that. I needed to multiply this also by the sine of 60 degrees. Just noticed it when I was putting it in my calculator. Alright, so I get that this whole thing is equal to here we go. 0 is equal to negative 14,129 pound-feet plus by times 20 feet. So when I rearrange that, I get by is equal to excuse me, 706.4 pounds. I'm sorry, excuse me. Okay, sorry, I'm back. Alright, now we need to find RAY. So we could just do that with a simple sum of the forces y. Goodness. There it goes. Now. Okay, so we've got RAY minus 120 minus 800 minus 400 sine 60 degrees plus RBY, which is 706.4. So RAY is equal to £560. Okay. So that's the solution to 424.